Hello and welcome to this video where we're going to learn about fractional indices. We're going to start by looking at when we have indices in the form 1 over n. So we have a 1 on the top and an n on the bottom of the fraction. The rule for this is as follows. We can read the right hand side here as the nth root of x. So what does this mean? Well, if we had x to the 1 over 2, then we're looking for the second root of x. Now we don't normally call this the second root. In fact, we don't even write the 2. We write it like this and we call it the square root. So if you have anything to the power half, you just need to do the square root of it. If n is 3, so it's the power 1/3, then we're looking for the third root of x. And again, we don't call this the third root, but we do write the 3, we call it the cube root. So we're looking for the number you multiply by itself 3 times to get to x. And this keeps going. So if you have x to the power 1 over 4, you're looking for the fourth root of x. X to the 1 over 5, the fifth root of x, and so on. Let's have a look at how you can do this with some actual numbers. So if we start with 25 to the power 1/2, this means we need to do the square root of 25, which is 5. If you had 36 to the power 1/2, this is the square root of 36, which is 6. And what about some with a power third? Well, 8 to the power third means we do the cube root of 8, so we're looking for the number we multiply 3 times to get 8, and that's 2, since 2 times 2 times 2 is 8. And how about 125 to the power 1/3? Well, again we do the cube root. So we're looking for the number we multiply 3 times to get 125, and that's 5. 5 times 5 times 5 is 125. Let's have a look at one with a quarter. So 81 to the power 1/4. That's the fourth root of 81. So we're looking for a number we multiply 4 times this time to get to 81. And this is 3. Since 3 times 3 times 3 times 3 once more gives you 81. And we can even do 32 to the power 1/5. Well, this means we need to do the fifth root of 32, so we're looking for a number that we times 5 times to get to 32, and that's 2. Since 2 times 2 times 2 times 2 times 2 again is 32. So far we've looked at questions where the index is in the form 1 over n, so there must be a 1 on the top of the fraction. But it doesn't have to be a 1. Now let's extend this to look at questions where the fraction is in the form a over b. So it could be any number on the top and any number on the bottom. You could write the fraction a over b as a product, 1 over b times a. So we could rewrite x to the a over b as x to the 1 over b times a. And you could use the bracket law for indices to write this as x to the 1 over b all to the power a. Now we know how to cope with situations where it's 1 over b. That will just be the bth root of x. So when we have x to the power a over b, first of all we do the bth root of x, whatever that is, and then raise this to the power a. Let's have a look at how we do this with some examples. So we've got 27 to the power 2/3. On the bottom we've got a 3, so we're going to start by doing the cube root of 27. Then once we've worked this out, we're going to put it in a bracket and raise it to the power 2, because there's a 2 on the top of that fraction. The cube root of 27 is 3, so we've got 3 squared, and 3 squared is just 9. So the answer to 27 to the power 2/3 is 9. Let's have a look at another one. So for this one we're going to look at 32 to the power 2/5. On the bottom we have a 5, so we're going to start by doing the fifth root of 32. Once we've found that, we're going to then square it, since we have a 2 on the top again. The fifth root of 32 is 2, we did that one earlier, so we've just got 2 squared, which is 4. Let's try one more. So for this one, we're going to do 16 to the power 3 over 2. Since we have a 2 on the bottom, we're going to do the square root of 16. And then since we have a 3 on the top of the fraction, once we found the square root of 16, we're going to cube it. So the square root of 16 is just 4, so we've got 4 cubed. And 4 cubed is 4 times 4 times 4, 64. So whenever you have a fractional index like this, you use the bottom number to tell you which root to do, and the top number to tell you what power to raise it to afterwards. It's also possible to do these in the reverse order. So for the first question here, if you really wanted to, you could do 27 squared first, and then cube root that. But in most cases, it's going to be easier to do the root first, and then raise it to the power afterwards. Now sometimes you may face questions that are a bit harder like this. So we have a fraction raised to the power 2/3. We know the power 2/3 means we do the cube root and then we square it. So all we do here is we raise both the numerator and the denominator to the power 2/3. So we do the same on the top and on the bottom. So let's create a fraction, and on the top we've got 27 to the power 2/3, which we know means the cube root of 27, and then you square it. And then on the bottom we've got 64 to the power 2/3, so that means the cube root of 64, and then we square that. So let's work these out separately. On the top, the cube root of 27 is 3, so we have 3 squared. And on the bottom, the cube root of 64 is 4, so on the bottom we have 4 squared. 3 squared is 9, so we end up with 9 on the top, and 4 squared is 16, so the answer to this one is 9 over 16. Now you can also combine this rule with some other rules of indices, for example the bracket law. As a quick reminder, if you have something like a to the power 4 to the power 5, you multiply the indices here. So this would give you a to the power 20. And also situations like this, 2b to the power 8 to the power 3, you will multiply the indices still, so 8 times 3, but you also need to factor in that 2. The way we do this is we first raise the 2 to the power 3, so 2 times 2 times 2, which is 8, and then we can multiply those powers. 8 times 3 is 24, so it's 8b to the power 24. A really common wrong answer to this question would be 6b to the power 24, where people multiply the 2 and the 3. But you don't do that, you raise the 2 to the power 3. This rule can be applied to fractional indices as well. So let's take a question like this. We're first of all going to raise the 16 to the power 1/2. So 16 to the power 1/2, we know that means the square root of 16, so it's 4. You can then multiply the indices together, so 4 times 1/2 is 2, so we have a to the power 2, and then 6 times 1/2 is 3, so we have b to the power 3. And that's that question done. And let's try one more. So this time we're going to start by raising the 125 to the power 2/3. This means we do the cube root of 125 and then square it. The cube root of 125 is 5, and then square this is 25. And then we can continue by multiplying the indices again. So for c to the power 12 times 2/3, we do 2/3 of 12, which is 8. And for d to the 3 times 2/3, we do 3 times 2/3, which is 2. So d to the power 2. You could even get a question that looks like this. At first it looks quite scary, but if you remember everything we've done in this video, we can break it down and do it. So first of all, we've got a fraction raised to a power. So we're going to raise the top to this power and the bottom to this power. So let's start by raising the top to the power 3 over 2. To do this, we'd raise 4 to the 3 over 2, which means the square root of 4, which is 2, and then we cube that, which is 8. We can then multiply 3 over 2 times the 6 and the 8 for the a and the b. So 6 times 3 over 2 gives you 9, and 8 times 3 over 2 gives you 12. We then do the same thing with the bottom. So 49 to the power 3 over 2, that's the square root of 49, which is 7, and then we cube that, which is 343. And then for the x and the y, we just multiply those indices by 3 over 2. 2 times 3 over 2 is just 3, and 20 times 3 over 2 is 30. So this is your answer.